metalheads. Today, we have for you a possible way for you to get your hands on some GPUs. If you've been tracking chip availability, seems to have been difficult for a while, but there may be some trickery. Here to tell me a bit more about that and the LaunchPad that we've worked together on are friends from NVIDIA, Vinay, and Chris.
Hey guys.
I was going to give you a good afternoon, but I suppose that's I'm not even sure of a time zone. Where are the both of you coming from?
So I'm from San Jose. And I live right next to NVIDIA headquarters, I guess. But yeah.
Excellent, Chris.
Yeah, I'm based out of Austin, Texas. So afternoon would be appropriate right now.
So that I did not know. I am also Austin, Texas, the south side of the city that smells like smoked meat most of the time. If the wind's blowing the correct direction.
Okay, yeah, I'm on the north side. I'm up closer to Georgetown. So yeah, not a whole lot of smoked meat winds coming my way.
Perfect. Can you tell me a bit about what you've been working on at NVIDIA?
Yeah, so I joined NVIDIA a little over a year ago. I work on the IT side of the house, primarily working with our virtualized infrastructure, which is predominantly on vSphere. And so my team, we work to provision and manage all of the virtualized infrastructure and interact with customers on that. I spend a lot of my time on the automation side of that effort, ensuring that we have the best uptime, availability, and resilience for our customers.
Okay. Vinay?
Yeah, so I joined NVIDIA a year ago as well. So I'm a performance engineer. I work on the on NVIDIA AI Enterprise. It's a suite of technologies that help AI practitioners get their infrastructure ready on an on-prem environment. We provide software on top and support to budding AI practitioners.
Okay. Yeah, I'd watched the GTC keynote, and so there was the portion that dealt with LaunchPad, which we'll be talking a bit about today, and then so much of that was AI infrastructure, which I'm a little less familiar with. How is AI infrastructure different from the compute, storage, network style infrastructure that I'm more familiar with?
Sure. Let's take this story a couple of years ago, right? When we talk about AI, what we generally mean is a paradigm of AI that has become popular in the recent years, right? It's called deep learning. And back in 2012, Alex Krasevsky, he pioneered the deep learning revolution. So what he did was he used CUDA, which is like our low-level C++ programming construct. And then he had this idea of using neural networks, right? Neural networks were popular since the 1980s. But the idea was that these neural networks were very shallow. What Alex did was that he kind of had this idea of what if I make this neural network deep, right? As in have a lot of layers in it. And that way, it would probably fit a lot of data and it would generalize better on real world use cases. So what he did was he used, like I mentioned, he used CUDA. And in order to train these neural networks, you require a lot of computation power. And so for which GPUs are the perfect resource. So he wrote his entire code on this programming language, CUDA, which is like a parallel programming language construct. And then he had good speed ups and he was able to train his model quickly. But the idea was that this programming language, it's not something a data scientist or an AI practitioner can use, right? It's complicated. It has context. It has thread parallelism. It has all the lower level details that's probably not familiar to data scientists. Over the years, the community has come up with abstractions on top, right? You have libraries like TensorFlow, PyTorch, MXNet, right? These libraries kind of abstract all those details away. And now you have this simple to use, simple to write frameworks on top of Python that that data scientists can use, right? But the underlying layer still uses CUDA and still runs on GPU. And to make these frameworks run, you tend to need a couple of things on top, right? Like to make the GPU, to make use of GPU, you need its driver, and then you need, CUDA on top. And what we have done, I guess, over the years is that we've made all that simple, all that much simple, right? The driver installation and then the libraries on top are abstracted away through containers. So that way, and then on the infrastructure side, of course, you need GPUs. On the other side, from a networking standpoint, there's something else that you also need. So over the years, the neural network that Alex trained was called AlexNet, right? It started with it was not as big as the neural networks are right now. So neural networks over the years have gotten bigger and bigger, and it takes more computation power to keep training them. Like, for example, Microsoft and NVIDIA recently trained a neural network that was for natural language generation that was 500 billion parameters. That has like 500 billion parameters to tune. The idea being that you can't fit all that amount of compute or all those weights of a neural network on a single GPU. And in which case, what you need is you need to split the neural network on multiple GPUs and then have copies over on multiple GPUs, right? Like from the beginning of time, you always did that. You broke the bigger problem into smaller problems, and then you gave each part of a problem to a smaller unit. So that's what they did with neural networks as well, right? Like big neural networks. And so the problem here then is to identify bottlenecks, right? Where would the potential bottlenecks lie? The GPUs have become fast over the years, right? Like with Ampere, which is like a really fast architecture for training neural networks. Then the bottleneck then lies with the network over which these parameters need to be trained, right? Like, so what happens is, let's say you have a big neural network and you have a big data set. You give a part of a data set to each neural network, a copy of neural network on a separate GPU somewhere. And then you basically divide and conquer. And these copies of the neural network talk to each other over the network. So we need high bandwidth interconnect between them so that the network doesn't become a bottleneck. So for that use case, you have Mellanox interconnects. They're high bandwidth, low latency networks, which use RDMA, right? It's a technology which is similar to TCP, but it has additional programming constructs on top of it. So the lower level APIs talk to these talk to these high bandwidth interconnect cards, and then you can train these neural networks quickly without the network becoming a bandwidth. So yeah, from a hardware perspective, you have high bandwidth interconnect, and then you have the GPUs in your data center.
Yeah, I'm hearing probably generates a fair amount of heat, probably takes a fair amount of power, and then size-wise, when watching the keynote, I saw beautiful gold boxes and tall racks and lengthwise, and so probably takes some time to set up. And then when you're talking about bottlenecks, I suppose it also depends where the data it's operating on is, and the closer you put the boxes of your GPUs and the machines that they're housed in to the rest of your data or whatever other infrastructure that you're running, I assume the faster the transfer is going to be.
Exactly. Yeah. So yeah, from a storage perspective, something that I probably missed is that we have something like GPU direct storage or NVMe or GPU direct or NVMe, right? Like so, the GPU direct storage is an interesting concept. It allows the GPU to consume data directly from the disks without the interference of the CPU and without the interference of the OS kernel. So in which case, what happens is you will not have a bottleneck associated with data read, right? And then it's basically keeping GPUs hungry for more data without having to rely on the CPU. So that's something that NVIDIA has also done.
And then, so what's going on with GPU? Anything going on with on the network card side that's also circumventing a CPU?
Yeah, or on the networking side. So what happens, like I mentioned before, you have a big neural network, right? And these big neural network have multiple copies of themselves on multiple GPUs. They need to share weights among each other. So the GPU to the NIC communication for exchanging these weights doesn't have to go through the CPU or doesn't have to go through the OS kernel level. So that way, it's called GPU direct, right? So from a communication of GPU to NIC to a remote GPU somewhere else without the intervention of OS kernel and the CPU. And that's quicker. That path itself is quicker.
Okay. And so to come back to LaunchPad, what is LaunchPad? That's the packaged up the machines, the software, data center, all in the data center, and then a front end for that, or even more than that?
Yeah, Chris, you want to answer that, or I can take it as well?
Yeah, so LaunchPad is the concept of providing that whole stack that Vinay just talked about, but in a couple of different remote data centers, leveraging the Equinix Metal capabilities and functionalities in your various globally distributed data centers, right? So that we can kind of bring that to our customers and to anyone else who's interested in trying it out. So LaunchPad is our way of kind of deploying and provisioning that infrastructure that Vinay talked about, but in those data centers that meet the customer where they're at so that they can test it out. We have a couple different flavors that we offer that we can probably get into of different capabilities to meet the customer's needs and expectations, because not all the customers are doing quite the same thing, right? So it's deployed to meet their expectations for their business cases. And we've been pretty successful and pretty excited about the collaboration with you guys.
Yeah. So who is that for? You don't have to name names if they've asked you not to. But what sort of uses and business cases are there?
Yeah. So Yeah, what we've noticed is that Launchpad at its core is just getting NVIDIA technology to potential customers, right? Both hardware and software. Uh, NVIDIA's both hardware and software products over to the customers. So what we've noticed generally is that it usually takes quite a few months for customers to kind of get their hands on the hardware to run their AI and machine learning jobs on, right? Like, or to test out NVIDIA technologies in general. So what we did is we collaborated with you guys, and then we use your bare metal as a service offering to kind of automate our environment, our technologies on top of Equinix Metal. And so what a customer can do is get instant access to your environment, like to our technologies on your environment. And that way they can take a look, see, do their own AI practitioner work, see how it looks, and then they can make informed decisions, right? So yeah, that's I guess the whole idea behind Launchpad. And I guess from a customer standpoint, we are having potential finance customers, some AI practitioner customers, right? I won't name names, but yeah, like somewhere around, yeah. So, and it just launched this GTC, and then we are seeing a good influx of customers.
Excellent. Yeah, it feels very much like the AI or data science version of the supercar experience, where you don't necessarily need a Ferrari every day, but if I want to make sure that that's the one that I want, you can have one for a day or for 2 days, and then put it back and have someone else use it. But makes sense to operate it in the environment where it would be, and not have to get on the list and wait forever, and then eventually
Yeah.
and then yeah, if that's not for you, or if you need much more, then be ready for have the ability to be ready for that.
Yeah.
How does the program work? Is there do you have anything you could show me?
Sure. So I'll walk you through a demo, but
Yeah.
before we start, I guess I can tell you how Launchpad works, right? You go to the Launchpad page, and then you register yourself as interested, and then one of the NVIDIA representatives reaches out to you, and we basically ask you what your use case is and what you intend to do, right? Like, just to get requirements for any customer who wants to take a look, and then we provision an environment for them on Equinix Metal. And there are many NVIDIA technologies that they can take a look at, right? For example, there's something like NVIDIA AI Enterprise, which is an enterprise grade set of software that NVIDIA that NVIDIA provides to potential AI practitioners. And then there is a Fleet Command, which is like an edge deployment use case. So you train your models in the data center with AI Enterprise, and then you deploy them at edge with Fleet Command. But yeah, so for today, I can show you a demonstration of NVIDIA AI Enterprise, right? Let's see if I can share my screen. Okay, so this is a Launchpad environment that we created for a customer. So ideally, this entire Launchpad, this entire environment, it's running on Equinix Metal, right? Like, it's running on the bare metal Equinix Metal server. Underneath it is a set of structure, right? you have your you have your vSphere environment, which is like a environment that a lot of customers use. So for example, you can just go and launch your vCenter environment, right, from your LaunchPad. You can go log in, and every customer who registers for this, we get their use cases, and then we provision this environment for them. And they get their own unique login and unique password and a unique vCenter for them. You can connect to your vCenter from here. And yeah, again, the login is different for different customers.
Sure.
These environments are created and destroyed at will, so they are ephemeral, for instance. So they get a 2-week trial on this environment, and then these servers get repurposed back for other use cases, right? For example, this is a vCenter environment, which is running AI practitioner VM, and it has like if you go here, it has like a A30 GPU in it, vGPU. And what a vGPU is we virtualized GPUs for vCenter or any other hypervisor, right? So that it becomes easier to manage VMs. So how in general, in general, you a virtualized environment virtualizes CPUs, right? Like let's say you have vCPUs, and then you have then you have vNICs and everything, right? Like this is familiar to someone who is already who already knows how vCenter works or how VM virtualization works, right? Like yeah, so in which case we also virtualized your GPUs, your NVIDIA GPUs, and you can add GPUs and remove GPUs at will on this VM. And then this is your for in this instance, this is my environment, right? This is something I created today. And then you can connect to vCenter, you can create VMs like these, and then you can log into these VMs, right? You can log into these VMs and you can check what GPUs your machines are using. In our case, it's using a A30, which is like a data center GPU. And then for a AI practitioner environment, you'll have something like this. You'll have, so AI practitioners generally tend to work on Jupyter notebooks. So we have Jupyter notebooks for them, right? Like we have various curated labs for them. And these labs generally tend to run on containers, right? Like we have NVIDIA supported containers for TensorFlow, PyTorch, Rapids, which is like a data science set of libraries, right? Which are similar to pandas and scikit-learn and all that. Like, so for example, QDF, which is Rapids QDF, is like a GPU implementation of something like pandas, and Rapids QML is a GPU implementation of something like scikit-learn. So we have all these set of AI data science tools and frameworks on top, and then you get to take a look at how these environments look like. Like for example, in our case, so this is a Jupyter lab, something that AI practitioner would be familiar with, right? And in this case, for example, we have a set of curated labs, right? Like for them to take a look at and for them to experience. In this case, this lab is predicting taxi fares with NVIDIA Rapids, right?
To check 1 second, I think you've either sent me a single window, but not the whole screen.
Oh, okay.
Possible to reshare right quick either the appropriate window or screen?
Yeah, let me see if I can. Do you guys see the Jupyter notebook now?
Got it now.
Yeah. So this is a Jupyter notebook that we kind of spawned from that previous environment, right? And in this case, we have a set of curated labs for you to experience the containers that we have on NVIDIA AI Enterprise. For example, there's a Rapids container, which is running New York City taxi lab, right? For example, this lab is what something Uber would do, right? Like gather historical data and predict new taxi fares from them based on something like latitude, longitude, pick up longitude, and drop off latitude and drop off longitude, right? Like predict fares. And you can take a look at the code and take a look at the Jupyter notebook. You can see all the libraries that are new in NVIDIA Enterprise. We use QDF. Like I mentioned, this is something like pandas. And then we have GPU implementation of XGBoost already in the container. So your XGBoost models get trained faster. And then you have Dask in it, which is, it's what Dask is that you can, it's something like Spark. You can scale your GPU jobs on multiple GPUs using Dask. So you guys can go through the notebook, read the data, inspect the data, clean the data, and then train a model at the end. And all of this runs on the GPU and this and the VM that I just showed you. So yeah, any questions?
Yeah, what is the speed difference from either running that on a reasonably quick gaming machine or on a say the MacBook, the Intel MacBook that you were issued?
That's a good question. Yeah. So it really depends on what the size of the data is and how the data, how big the data set is. As the data set keeps getting bigger, you will see a bigger difference, right? Like between something like an A30 and something like running it on a MacBook Pro, right? If it's a few megabytes long or a few megabytes big, then you'll probably not notice a difference. But as it goes into GBs, as you train bigger models, you'll see a 10x speed up, or and that difference gets much more pronounced on deep learning, right? Where you see 100x speed up or something like. It depends on what you're actually running, but yeah.
Excellent. If you're watching, happy to take additional questions from the chat before we end up wrapping. I suppose I can also throw up a link there. I dropped a link in the chat if you're interested in giving the LaunchPad a spin. If you're in the chat, or you can type that out, or if you're a friend from the future watching this video, it'll be down in the show notes that you can take and click through there. Don't see additional questions coming in. Excellent. Thanks so much for that. Did you have anything additional that you'd like to leave folks with?
Chris, anything you want to add?
No, I think that Vinay did a really good job. One thing to note is that the way the AI Enterprise LaunchPad stacks are deployed, those are two different personas. So we really meet the customer where they want to be, right? So we worked really hard to kind of create a fork in the road where you, from my perspective, I spend a lot of my time on IT, right? So I don't spend as much time inside of a Jupyter Notebook so much as providing that back to what I would consider a customer. So there's a whole IT admin aspect, and there's a lot of the labs that Vinay was pointing at there where you get to interact directly with the vCenter server. You provision VMs directly on that instance. You provide the the pass through, and you can tune some of the parameters there and really get a feel for what it's like inside of the environment as a customer. And then the AI practitioner kind of picks up from that point, right, where now you have a Jupyter Notebook deployed from your IT admin perspective, and you kind of pick up from right there. So it was fun to work on this, kind of get to see both sides of that coin, right? So we really worked hard to make sure that everyone's use cases were accounted for, because some of these customers are coming to us with, hey, we have both of these, right? We want to play with the IT perspective, and we want to play with the data science perspective, and so we could provision one for both sides of that house and give them a really holistic view of what AI enterprise can bring to bear before they even have to make a purchase.
Yeah, no, being able to test drive, especially in a place that's geographically near you, is real nice.
Yeah, and I think one of the interesting things and great things about this collaboration was after we got into it, we realized that there really wasn't a degradation in terms of performance or in terms of the user interaction and responsiveness, whether it was someone in the US interacting with an instance in one of your data centers in, say, Paris or Frankfurt, or the inverse, right? So that was actually great. So we have the ability to provide this all over the world, right? So we have a huge amount of availability, and the customer doesn't necessarily have any sort of impact. So the locality issues actually were reduced on doing this with you guys, working on your guys' metal platform. So that was awesome to see, because that was a really nice benefit that we didn't expect to have as an outcome.
Very cool. Yeah, and I suppose I'll say again to close us, if you are looking to give a try, stop by the link. It'll throw the info in the form, and you can be giving the GPUs a spin at your with either your own data, or take it work through the labs there. All right, with no further questions, Vinay, thanks so much. Chris, thanks so much for joining me here. We'll see you before too long. Bye for now.
Yeah, appreciate it. Bye. Thanks.
Bye.